Good morning, everyone. Today, let me discuss about the methods of population forecasting. So, in a previous class, we have done the problems on other methods of population forecasting. So, today we'll solve the problems based on the decreased rate of growth method and logistic curve method. Okay. So, shall we start? Okay, we'll start. The decreased rate of growth method. So when do we prefer the decreased rate of growth method? So here when the city reaches the saturation level, so then when the population goes on decreasing from decade to decade, that means the city reaches the saturation level. So in that situation, so we are use the method called decreased rate of growth method. And other methods we have discussed, there are many number of methods are there. In the previous classes we have done problems based on the other methods. So these two are the remaining the methods of population forecasting. The decreased rate of growth method, so we know that now. So when the city reaches the saturation level, so in that particular situation, so we use the method called decreased rate of growth method. And one more method is there, that is logistic curve method. So in logistic curve method, so when do we prefer this logistic curve method? The actually in logistic curve method, before that, so most commonly we are taken the three factors which are responsible for the changes in population. We know that is the birth, death and migration. But this particular logistic curve method is based on the hypothesis that it do not produce the extraordinary changes in the birth, deaths and migration, and the population would probably follow the growth curve characteristics of living things within limited space and with limited economic opportunities. So that is the logistic curve method. Okay, let me solve the problems on decreased rate of growth method and the logistic curve method. Okay, the problem is given like this. So here the population statistics pertaining to a town are given below, and we have to estimate the expected population for 3 decades using decreased rate of growth method. So this is the problem, and here the problem is given, the year is given, population is given. So here the data is given are only the year and the population. So only 2 columns will be given in the problem, whereas the year and population. So the rest of 3 columns, so increase in population, percentage increase in population, percentage decrease in population, we have to solve. Okay. So year is given in 1930, the population is 25,000, whereas in 1940, 28,000, in 1950, 34,000, whereas in 1960, 42,000, and in 1970, 47,000. So only these 2 columns were given in the problem. Next column, so we have done the same type of problem in, that is the incremental increase method. There we calculated what is the increase in population. That means 1940 population is there now, that is a 28,000. So here we have to calculate that means a subtraction we have to do. That means 28,000 minus 25,000. So that gives the population of, that is 3,000. That is a 25,000 minus 28,000 minus 25,000. What will be the answer? So it is 3. That is, it will be that is 3. 28,000 minus So sorry, it is interchanged. So 28,000 minus 25,000, it gives rise to the value of 3,000. That is the increase in population from 1930 to 1940. Okay. And in 1950 to 1940, for one decade, then what will be the population increase? That means 34,000 minus 28,000, that gives the value of 6,000. And whereas in 1960, 42,000 is the population, and the increase in population is 42,000 minus 34,000, that gives rise to 8,000. And whereas in 1970, it is 47,000, the population is 47,000, that means the increase in the population is nearly 5,000. 47 minus 47,000 minus 42,000, that gives the value of 5,000. So this is how to calculate the third column, that is the increase in population. Whereas in the fourth column, so we have to find out what is a percentage increase in population. What is the percentage increase in population? So for that, we have to calculate like this. That means 3,000 divided by 25,000 multiplied with 100, it gives the value in terms of percentage, that is 12%. And for second, that is 6,000, whatever the increase in population we got from the third column, so that we have to place it in a replace it, that is 6,000 divided by 28,000 multiplied with 100 gives the percentage of 21.4%. And next 8,000 by 34,000 gives the value of 23.5%. And the last, that is 5,000 divided by 42,000 multiplied with 100, which gives the value of 11.90%. That is a percentage increase in population. We have done the same type of problem we have solved in, that is incremental increase. Till year it is same, that is a percentage increase in population. So one more column which is included here for decreased rate of growth method. So till year, till the fourth column, it is same as well as the incremental increase method. Whereas in the decreased rate of growth method, that is we have to find out what is the percentage decrease in population. So for that, we have to take, that is a 12% minus 21.4%. So that gives the value, 12 minus 21.4 is minus 9.4%, and 21.4% minus 23.5 is equal to minus 2.1. And finally 23.5% minus 11.9%, it gives a value of 11.6%. It gives a value of 11.6%. So here, so minus 9.4 minus 2.1 plus 11.6 divided by 3. So we have to take the average. What we calculate, we have calculated that percentage decrease in population, that is minus 9.4 minus 2.1 plus 11.6 divided by 3 gives a value of, that is I naught, that is gives the value of, sorry, gives the value of dr. Dr is nothing but that is a decrease in percentage of population. So that represents the value of, that is minus 9.4 minus 2.1 plus 11.6 divided by 3 gives a value of, that is dr, that is the decreased percentage. So next let me move on the formula. So what is the formula for that? That is Pn, that is whatever the future population, that should be equal to P naught. So whereas P naught is the last year, that is the previous year, that means in 1970 is the previous year, previous decade, 1970. In that 1970 year, the what is the population? 47,000 plus So within the bracket, after plus, within the bracket, the formula is I naught minus dr divided by 100 into P naught. So this is the formula which we are given, that is P naught plus the P naught is the last year population, last decade population we have to substitute. I naught is the last decade percentage increase in a population that we have to substitute, and the dr is the average, the percentage of decrease in population that we have to substitute, divided by 100, and which is multiplied with the p naught, the same, that is the previous decade population we have to substitute. Look at the previous slide. So here, what is the percentage, the last decade, what is the population, then what is the P naught? It is 47,000, no? And the what is the percentage increase in population for the previous decade in 1970? It is 11.90. Then what is the average decrease, percentage decrease in the population? It is minus 9.4, minus 2.1, plus 11.6 divided by 3. Please make a, using a calci, then calculate. What is the value now? So minus 9.4 minus 2.1 plus 11.6. It gives a value of, divided by 3. Divided by 3, it gives a value of 0.03%. So that is the value of dr. So here the formula is Pn. That means we have to find out the population of the next 3 decades. That means 2000. Now the last previous year decade is 1970. So next 3 decades means 80, 1980, 1990, 2000. So we have to find out or to estimate the population of, that is in a year of 2000. So for that, the formula which is given as, that is Pn, that means a P 2000 is equal to P naught plus, within a bracket, I naught minus dr divided by 100, that is multiplied with the P naught. So within a bracket, so I naught minus dr divided by 100 multiplied with the P naught, then we have to add up with the P naught value. So first we have to multiply it with P naught, and finally we have to add up the value with the P naught value. So now let me come to the formula. Pn is equal to P naught plus I naught minus dr divided by 100 into P naught. And here the note. So I have given one note. The value of I naught minus dr for the next decade population calculation. So I naught minus dr of the present decade will be the value of I naught for the next decade. Look at here. So we have to find out what is the estimated population in 2000. So for that, so first let me do the calculation for the population in the 1980. Okay, 47,000. It's a P naught, that is a previous decade population, plus within bracket 11.9 is the previous decade, the percentage increase in population, minus 0.03 is the average percentage decrease in population. We have done it, no? Minus 9.4 minus 2.1 plus 11.6 divided by 3. That value we have to substitute here. That is the dr. I naught is 11.9 is the previous year percentage increase in a population, whereas 0.03 is the average decrease in a population, that is a 0.03 divided by 100. Then we have to multiply it with the 47,000. Finally this value should be add up with the 47,000. That gives the value of, that is 52,579. Please do the calculation. Open your calcs and do the calculation. So this is how to calculate the next decade population by using a decreased rate of growth method. Whatever the values will be given, so the year and the population. So in any method of population forecasting, the only the given data are the year is given and population is given. So we have to use we have to use the particular the formula for the particular method. Okay, for decreased rate of growth method, this is the formula, that is Pn is equal to P naught plus I naught minus dr divided by 100 multiplied with P naught. So that should be multiplied with the P naught value. First we have to multiply with P naught and add up with the P naught. So this, the value will be that is the value, the population in the year 1980 is equal to 52,579, and the same way after calculation. So what is the previous decade population? Here we should not substitute the 47,000 because in 1980 is the previous data we have to take in, that is the P naught value. So whatever we got, whatever we calculated the population of 1980, we have to take that value as a P naught. Okay, so 52,579 plus, so first we leave this, that is 52.579. So 11.87 is, so what is the 11.87? So in the note have given that the value of I naught minus dr of the present decade will be the value of I naught for the next decade. That means 11.9 minus 0.03, it gives a value of 11.87. So that is the note have given that in the previous slide. So note, the value of I naught minus dr of the present decade will be the value of I naught for the next decade. So that is 11.87 minus 0.03 divided by 100. That should be multiplied with the 52,579. Again, we have to add up with 52,579. The P naught value will be same as we multiplied with the same P naught value, and the same we have to add up with the P naught value. The P naught, it should be the previous decade. So that you have to keep it in mind. Okay, then we have to find out what is the population in a P2000. So same way, so here we have to substitute, instead of 52,579 for P2000 calculation, we have to substitute 58,804 plus 11.87. So 11.87 minus 0.03 will be the I naught value, that means 11.84. so will for P, the population for population for P2000. So let us show. Okay, so here so see here, look at here. So for P2000 is equal to, what is the value we have received? The value we have received is equal to, that is 58,804 is the population of the P19. So P1990 plus, so here we have to, so this is the I naught value is 11.84 minus 0.03 divided by 100, and that should be multiplied with 58,804. So first we have to solve the problem, that is the 11.84 minus 0.03 divided by 100 into 58,804. Then afterwards we have to add up with the 58,804. What is the final value? That is 65,748 is the population after 3 decades. So this is how to calculate what is the population in the year of 2000. Okay, I think it is clear. So let me discuss. Okay, this is how to calculate the what is the population in the P2000. So the population is 65,748. Okay. Okay. Let me move on to the next method, that is the logistic curve method. Okay. In a logistic curve method, so we solve the problems based on the hypothesis, that is a logistic curve method. It is based on the concept, that is a hypothesis, that the population will not completely depend upon the three factors, that is a birth, deaths and a migration. So the population would probably the follow the growth curve characteristics of the living things within limited space and with limited economic opportunities. We know that. So let me solve the problem based on the logistic curve method. The population of a city in 3 consecutive years. So year, that is a 3 consecutive years is given. That means the 1991, 2001, 2011 is given. So the only in all other methods also they have given only two data. One is the year and the next is the population. What will be the population? So year in 1991 the population is 80,000. And in 2001 the population is 2,50,000, and in the year 2011 the population is 4,80,000 respectively. Determine the saturation population, the equation of logistic curve, the expected population in 2021 we have to calculate. So expected population in 2021 we have to calculate. First, we have to find out what is the saturation population and the equation of the logistic curve and the expected population in 2021. Here some formulas are there and those formulas are very simple. So those formulas very simple. So first we have to find out what is the saturation for population. Before that, we have to take down the decades. That is in terms of, we have to take down so this is the data, whatever the data which is given, you have to note down like this. What is the P naught value? That means the population in the year, that was the first year 1991, the population in, that is 1991. What is the population in the 1991? That should be the P naught value, that is 80,000. So here the P naught value is 80,000 and the P1 value is 2,50,000 and the P2 value is 4,80,000. So this is the what we have to note down. And what is the T, time taken? So the T naught is equal to 0 and the T1 is nothing but that is 10 years. The from year to year, what is the difference of years is from one decade to one decade is 10 years, and the T2 is equal to, that is 20 years. This we have to take down. Solution. In the solution, this we have to take down. That means the P naught value in year 1991, the population is 80,000, that is P naught. In 2001, the population is 2,50,000, that is P1. And in the year 2011, the population is 4,80,000, that is P2. And the T naught, the initial time in years is 0. And the T1 is equal to 10 years. And the T2 is equal to 20 years. So here, these are the formulas which are given. That is the PS is the saturation population. So PS, we have to remember this formula. That is PS is equal to, very simple. So whatever that is the PS is the saturation population is equal to 2 into P naught into P1 into P2. So very simple, P naught value, P1 value, P2 value multiplied with 2 minus P1 square in a bracket P naught plus P2 divided by P naught P2 minus P1 square. Very simple. So only we have used the population. Saturation population can be found out by using the formula 2 into P naught into P1 into P2 minus P1 square in a bracket, that is P naught plus P2 divided by P naught into P2 minus P1 square. So this you have to remember this formula. So P0, P1, P2. So only we have used the three datas. P0, P1, P2. Only these three population datas we have taken in the formula. 2 into P0 into P1 into P2 minus P1 square into P0 plus P2 divided by P0 P2 minus P1 square. This is the formula to find out what is the saturation population. And the M and N are constant values. So that we have to calculate the M value and N value. So M is equal to PS minus P0 divided by P0. So whatever we have calculated from the saturation population, so we have to substitute here PS. PS is the saturation population minus P0 value is the population. Initial population is 80,000 divided by 80,000. So this gives the M value. And N is equal to 2.3 into T1. What is the T1? T1 is 10 years. 2.3 divided by 10 log of, so we have to find out, that is the P0 PS minus P1 divided by P1 into PS minus P0. So this is a formula. So you have to remember these formulas. Okay. So these are the formulas you have to remember. Then the next we'll move on to the how to solve the problem. So you'll see here the saturation population can be calculated by using the equation. So we know that now we are familiar with the equation. That is saturation population equation is PS is equal to 2 into P0 P1 into P2 minus P1 square of P0 plus P2 divided by P0 into P2 minus P1 square. So just we have to substitute the value, that is a population value. 2 which is multiplied by 80,000 is the P0 population. 2,50,000 is the P1 population. 4,80,000 is the P2 population minus P1 square. That is a P1 square. That means a 2,50,000 multiplied by 2,50,000. That means instead of squaring, they are taking it twice. That is a 2,50,000 multiplied with 2,00,000 population. That is multiplied with P0 plus P2. P0 is 80,000 plus P2 is 4,80,000 divided by P0 into P2 minus P1 square. So that gives a value 6,55,602 is the saturation population. This is how to calculate the what is the saturation population. Then after that we have to find out what is the M and N. So that M, N and PS value, M and N value should be substituted in the next formula. That is the final formula to find out what is the future population. Okay. Then what is the M formula? M is equal to PS, that is a 6,55,602. That is a PS minus P0 80,000 divided by 80,000. So that gives the value of M. So that gives the value, that is M. So look at here. We have M. M is equal to PS minus P0 divided by P0. That means 6,55,602 minus 80,000 divided by 80,000 gives a value 7.195. That is a M value. And N can be calculated. That is 2.3 divided by T1. T1 is 10 years. Log 10. P0 is 80,000. PS is 6,55,602 minus 2,50,000 is the P1 value. And divided by P1 is 2,50,000. In a bracket, PS is, that is 6,55,602 minus 80,000 is the P0 value. This gives the value of minus 0.1488. So this gives the negative value, that is a N is equal to, M is equal to 7.195 and N is equal to minus 0.1488. So this is how to calculate m and n values along with the ps. Now this ps value, m and n value should be substituted in the main formula, that is the main formula. This is the main formula to find out what is the population in 2021. So this is the population in 2021 should be calculated by using this formula. P is equal to ps divided by 1 plus m log e to the power of minus 1 into n into t. So here for log e to the power of minus 1, for that, P 2021 should be population in the year 2021 should be calculated by using the formula, that is P. So you have to remember 4 formulas. One is the PS formula, another one is the M formula, N formula, and as well as this formula, that is P is equal to PS is the saturation population divided by 1 plus M log e to the power of minus 1 in terms of, that is n into t. So we have to calculate this. So here I will show the how to use the calci for this, the substitution. For 7.195 into log e to the power of minus 1, log e to the power of minus 1 is, look at here. So we have to, the log e to the power of minus 1, we have to take it as, that is alpha e to the power of, in a bracket, so we got the value of minus 0.1488 into 30. So like this we have to substitute e to the power, that means alpha e to the power and within a bracket minus 0.1488 into 30. So that should be multiplied with 7.195. So then you have to make other 0 and plus 1, then 6,55,602 divided by answer is, that is 6,05,436 population. Population in 2021 is 6,05,436 population. I think we have got the same value in a calci. So for log e to the power of minus 1 means alpha e to the power within a bracket minus 0.1488 multiplied with 30. So that gives the correct value. So this is how to calculate the future population by using the decrease rate of growth method and logistic curve method. I think students, I think you have, now you are confident to solve this problem. I think so. Yes or no? So you can solve the number of problems now, that is the decrease rate of growth method and logistic curve method. Okay, thank you. Then all the best.